This is the Type 003 Fujian. More than a ship, it is a declaration of intent. China built this aircraft carrier with a clear geopolitical purpose in mind: to redefine the balance of power in the Pacific. Its name, Fujian, is no accident. It represents the Chinese province directly across from Taiwan. Because of this, Beijing spared no expense, transforming the Fujian into the most capable and technologically advanced aircraft carrier ever built outside the United States. A true game-changer in global naval strategy. The launch of the Fujian in June 2022 marked a historic moment, signaling China's rise as a blue-water naval power, capable of projecting power far beyond its coast. This ship is the centerpiece of China's ambition to become the dominant force in the Indo-Pacific, directly challenging the American naval hegemony that has endured since World War II. Its existence changes the strategic calculus for all countries in the region, forcing them to re-evaluate their defenses and alliances. The construction of the Fujian is a testament to China's naval engineering capability and its commitment to achieving military parity with Western powers. The first thing to understand about the Fujian is its scale. It is colossal. At just under 316 finders, centimeters, 1 through 37 feet, long and nearly 76 meters, 250 feet wide, with an estimated displacement between 80,000 and 85,000 tons, the Fujian is the largest warship China has ever put to sea. In naval combat, size is a force multiplier. Being significantly larger than its predecessors, Liaoning and Shandong, means the Fujian physically has more space to accommodate more aircraft, more fuel, more ammunition, and a larger crew, drastically increasing its sustained combat capability. Its flight deck area is massively larger, which is a critical factor for the efficiency of air operation, allowing for the simultaneous movement and parking of a greater number of aircraft. The crew, although smaller than that of nuclear-powered American carriers due to automation, is still a considerable force of thousands of sailors, technicians, and pilots. China took advantage of this extra capacity. The Fujian weighs over 20,000 tons more than its predecessors. This additional weight is distributed across more powerful propulsion systems and a denser combat infrastructure. To move this mass, China invested heavily in an innovative propulsion system designed to maintain a maximum speed above 30 knots, about 56 km/h. Although it is not nuclear-powered like the American Nimitz and Ford-class carriers, China sought to optimize its conventional propulsion to ensure the speed and range necessary for long-range operations. The ability to maintain high speed is vital to generate the apparent wind necessary for the safe launch and recovery of aircraft, especially on calm days, a factor that is crucial for the aircraft's sortie rate. The conventional steam propulsion, while less flexible than nuclear, has been refined to provide the continuous power needed. The true technological leap of the Fujian lies in its propulsion and power system. While traditional aircraft carriers use power generation systems independent of the main engines, the Fujian adopts an integrated electric system, IES. This technology, similar to that used in American Zumwalt-class destroyers, revolutionizes power distribution on board. The IES is what allows the Fujian to operate its high-demand electromagnetic systems. The adoption of the IES is a milestone, as it allows the generated power to be flexibly directed to propulsion or to combat system, depending on operational need. The IES works like this. High-power boilers, fueled by diesel oil, generate an enormous amount of steam. This steam drives high-power turbines, which are coupled to generators. The generated power not only meets the electrical needs of the entire ship, lighting, radars, combat systems, life support systems, but also powers electric motors connected directly to the propulsion shafts. This arrangement is known as Integrated Electric Propulsion, IEP. The system is designed with redundancy, using 8 boilers and 4 shafts, ensuring that the ship can maintain propulsion even in the event of combat damage or during maintenance, increasing the ship's resilience. The benefits of this system are undeniable and crucial for combat survival: redundancy and resilience. As long as one engine is running, there will be power throughout the ship. The system is modular, meaning a failure in one component does not compromise the operational capability of the entire ship. Power on demand. The Fujian can generate large amounts of power instantly, adjusting needs in real time without the need to turn on or off auxiliary generator. This is vital for its most sophisticated weapon systems, such as EMALs and active electronically scanned array (AESA) radars, which require power spikes. Acoustic stealth. The elimination of complex and noisy reduction gears for propulsion makes the ship significantly quieter, a subtle but important tactical advantage in a high-threat environment, especially against submarine. Fuel efficiency. Although it is diesel-powered, the IES allows the engines to operate at their optimal efficiency range, reducing fuel consumption compared to traditional mechanical propulsion systems. This, in turn, increases the ship's operational range, extending the time it can remain on patrol. But, after all, what systems require such gigantic power consumption? The answer is the Fujian's secret weapon, the Electromagnetic Aircraft Launch System, EMALs. On the Fujian's deck, there are 3 EMALs catapults, 2 on the main runway and 1 on the angled flight deck. This allows for near-simultaneous aircraft launches. The presence of 3 catapults, instead of the 4 on the USS Ford, optimizes deck usage, allowing for a significantly higher aircraft sortie rate than ski jump carriers. EMALs is a quantum leap over the old ski jumps used on previous Chinese carriers. Instead of steam, it uses electromagnetic rails to provide a precise and adapted push. Think of it as a maglev train applied to launching fighters. The operating principle is based on linear induction motors, which use electricity pulses to create a magnetic field that accelerates the catapult shuttle. The great advantage is precision. In a traditional steam system, catobar, the launch force is the same for all planes. This causes unnecessary stress on lighter aircraft and can limit the launch capability of drone. EMALs, however, offers a pan-customized launch (ID), applying only the exact force needed for each type of aircraft. This not only increases the aircraft sortie rate, the ability to launch planes quickly, but also reduces the structural wear of the aircraft by up to 30%, prolonging their lifespan. With EMALs, the Fujian can launch a much wider range of aircraft, including the future J-35 stealth fighters and heavy drones, which was impossible with the ski jump. The ability to launch heavier aircraft with maximum fuel and armament load is a crucial factor that EMALs unlock, increasing the range and lethality of the air wing. Want to understand how EMALs works in detail and how it changes naval warfare? Leave a comment below with the word EMALs, and we'll make an in-depth video on the topic. Also, if you're interested in naval combat simulation, check out the link in the description for our sponsor and receive an exclusive welcome package. EMALs is not the only innovative technology copied from the USS Gerald R. Ford. The Fujian also incorporates the Advanced Arresting Gear, AAG, the Advanced Aircraft Recovery System. Traditionally, arresting cables used complex hydraulic system, prone to leaks and creating bottlenecks in flight operations. Although they could adjust pressure for different aircraft, the process was not instantaneous. The AAG solves this by using an electromagnetic system and water turbines beneath the deck. Control is fully digital, allowing for real-time adjustments. The AAG allows the same gentleness of EMALs to be applied to the arrest. It can adjust the necessary force to stop aircraft instantly and precisely, resulting in softer and safer landing. This reduces stress on the aircraft and, crucially, allows the Fujian to recover more aircraft more quickly, increasing the machu-to-sortie generation rate and maintaining pressure on the enemy. The reliability and reduced maintenance needs of the AAG also contribute to the ship's operational sustainability on prolonged missions. Although the focus is on strike power, the Fujian is a defensive fortress. It incorporates state-of-the-art point defense systems, HQ-10, a point defense surface-to-air missile designed to shoot down incoming anti-ship missiles at short ranges, 3 to 6 nautical miles. These missiles are supersonic, about Mach 2, and use proximity fuses, ensuring the destruction of approaching targets. The Fujian has at least 2 of these systems, each with capacity for 8 missiles, mounted on fixed launchers on the top. Type 1130, CIWS. The Fujian's last hope. This close-in weapon system is the latest iteration of the Chinese CIWS. If a missile manages to get past the HQ-10, the Type 1130 comes into action. It has an independent radar to track and engage targets. Its firepower is astonishing. 10,000 30mm rounds per minute from its 11 barrels. It is literally a wall of lead designed to disintegrate any approaching threat. The Fujian has 3 of these systems strategically positioned, ready for the final defense. The precision and rate of fire of the Type 1130 place it among the deadliest CIWS systems in the world. If you are impressed with the Fujian's defense capability, show your support. Like this video and subscribe for more analyses on the naval arms race. Your like is our fuel to continue investigating the technologies that shape the future of warfare. China has been discreet about the ship's non-kinetic defense measure, but we can safely assume that the Fujian possesses chaff and flare launcher to expel clouds of metallic fragments and heat decoys, confusing radar, and infrared-guided missiles. Electronic warfare, EW systems, to jam and interfere with enemy drones and communication systems, including the ability to blind radars and disrupt data links. However, the level of sophistication of these systems is unknown. It is not known whether the Fujian has advanced countermeasures comparable to American systems, such as the decoy launcher, sophisticated decoy, or the Nixie, towed anti-torpedo decoy, designed to attract torpedoes. China's lack of transparency about these non-kinetic systems is, in itself, a strategic tactic, forcing adversaries to overestimate or underestimate its electronic warfare capabilities. The real problem for adversaries is the Fujian's air wing. Although the exact number is unknown, estimates point to about 60 aircraft, and 12 more than the previous Chinese carrier, but still about 15 fewer than the maximum capacity of the USS Ford. The probable composition is about 40 fixed-wing fighters, forming the core combat force. J-15, Flying Shark. The J-15, a modified copy of the Russian Su-33 flanker, will fill most of the squadrons. Despite being older, the J-15 is a powerful multi-role fighter, modified to withstand the stress of carrier operations. Its additional weight, about 17,700 kg, and the need for more powerful engines, locally manufactured, give it an impressive power-to-weight ratio and a maximum speed of Mach 1.3. It is the Fujian's main strike and defense aircraft. 32 Deep-Hydrovator, CPVO, Future Stealth. The stealthy J-35, formerly known as FC-31, is China's bet for the future. Although still in the testing phase, it is the Chinese equivalent of the American F-35. Its full integration into the Fujian, enabled by emails, will represent China's true leap in combat capability, giving it a first-rate strike capability. The remaining aircraft would be helicopters, essential for anti-submarine warfare, ASW, attack, and transport. K-52 Alligator. Russian-designed attack helicopters, comparable to the American Apache, heavily armed with air-to-surface missiles and a 30mm cannon used in anti-surface roles. Z-20, a direct copy of the American Black Hawk, but with 2 crucial differences. 5-bladed rotors for better performance at high altitudes, such as in Tibet, and fly-by-wire controls, which make it more responsive and easier to fly. The Z-20 is the backbone of the Fujian's transport and anti-submarine warfare. If we remove the escort submarines and ballistic missiles from the equation and analyze only the 2 aircraft carriers, the USS Gerald R. Ford still has a clear advantage. So, air wing. The Ford carries more aircraft, about 15 more. Furthermore, American fighters, FA-18E/F and F-35C, have more advanced avionics, electronic warfare systems, and communication, making them more manageable and increasing their survivability. The armament and fuel capacity of American fighters also ensure that they can deliver harder blows for for longer. Nuclear propulsion. The Ford's nuclear propulsion is the biggest difference. It allows the ship to move at higher speeds for unlimited time, which is crucial for evasive maneuvers and for creating favorable wind conditions for aircraft launch. The Fujian, diesel-powered, would have to worry about refueling, logistics, and sustainability. China's capacity to perform underway replenishment, RAS, is still limited. In a prolonged combat, the concern about fuel consumption and logistics would become a burden on the minds of Chinese commanders. The Ford, with its nuclear reactor, eliminates this concern, allowing it to operate anywhere in the world for much longer periods. However, the U.S.'s biggest competitive advantage is not in a weapon system, but in something intangible, practical experience. The U.S. has conducted sustained flight operations on aircraft carriers for over 80 years in countless high-intensity conflicts. China simply lacks the combined generational experience of sailors, from the lowest ranks to the admirals, to operate such a complex platform under stress. It is this experience, this combat tested on an operational readiness, that can be the decisive factor in a confrontation between the Ford and the Fujian, coordinating hundreds of movements on the flight deck, maintaining complex systems in hostile environments, and the ability to quickly recover from failures are skills that take decades to master and that the U.S. possesses in abundance. The future of naval warfare is being written now. What is your opinion? Does American experience outweigh Chinese innovation? Leave your comment, and don't forget to subscribe to the channel and hit the bell for more content like this. Your engagement is vital to our work. The Fujian also stands out for its radar technology. It is equipped with a dual-band active electronically scanned array, AESA radar system, which is the Chinese equivalent of the USS Ford's state-of-the-art radar. This AESA radar is crucial for long-range detection of air and surface threats, and for guiding the ship's defense missiles. Furthermore, the Fujian's design incorporates stealth elements, such as the more compact island superstructure and the integration of antennas, seeking to reduce its radar cross-section, RCS. Although it is not a stealth ship in the strict sense, this signature reduction makes detection and tracking by enemy systems more difficult, increasing its survivability in contested environments. The Fujian's island, in particular, is a highly integrated command and control center, with multifunctional consoles and sensor data fusion, which increases the crew's situational awareness. The launch of the Fujian is a milestone in the global naval race. It forces Western navies, especially the U.S., to reevaluate their strategies in the Pacific. China has demonstrated its ability to take a quantum leap in technology, skipping the generation of steam catabar carriers and going directly to electromagnetic systems. This shows that China is willing to invest whatever it takes to achieve technological parity with the U.S. The Fujian is not just a ship, it is the symbol of a new era of geopolitical competition, where dominance of the seas will be determined by technology and the ability to project air power. The future of global security may depend on how the Fujian and its successors are used on the international stage. China plans to build more Type 003 class carriers, solidifying its position as the world's second-largest carrier force. A crucial aspect that differentiates the Fujian from its predecessors is the modern approach to maintenance and training. China, by adopting the IES, EMALS, and AAG, embraced complexity, but also efficiency. The Fujian's design likely incorporates advanced condition-based maintenance (CBM) systems, which track component performance in real time. This enables predictive maintenance, reducing downtime and life cycle costs. On the training side, the complexity of the new systems requires a more rigorous and modern training program. China is likely investing heavily in advanced simulators and virtual reality to familiarize crews with the electromagnetic flight deck and combat system. The ability to operate these complex systems with proficiency will be the true test for the Chinese Navy. Logistics aboard the Fujian have also been revolutionized. The ship's design includes an optimized hangar and flight deck layout to reduce the handling of materials and weapons. The weapon elevators, which are now electromagnetic, transport ammunition more directly and safely from storage areas to aircraft on the deck. This increases the safety and speed of rearming, a critical factor for sustaining the pace of combat. The ship's range, although limited by diesel propulsion compared to nuclear, is maximized by the efficiency of the IES and an improved capacity for underway replenishment. The Fujian is a war machine designed to operate with maximum sustainability and minimal disruption, a fundamental requirement for power projection over long distances and in high-threat environments. Despite all the technology, the human factor is the most unpredictable. The Fujian's crew will face a steep learning curve. Operating a catabar, catapult-assisted, takeoff but arrested recovery, carrier is inherently more complex than a stowbar. Short takeoff but arrested recovery. Carrier, like China's previous ones, coordinating the flight deck, maintaining electromagnetic systems, and integrating new stealth fighters will require a level of proficiency that the Chinese Navy is still developing. American experience, accumulated over decades of continuous operation, is an advantage that cannot be bought or copied. The Fujian's success will ultimately depend on China's ability to quickly train a highly specialized workforce to master this new generation of naval warfare. Although the exact cost of the Fujian is not publicly known, it is undeniable that the investment in research, development, and construction is massive. However, China sees this cost as a strategic investment. The Fujian's value is not only in its combat capability, but in its deterrence capability and power projection. It allows China to defend its maritime interests in contested areas and demonstrate its ability to intervene in regional crises. The operational cost, although lower than that of a nuclear carrier, is still significant, but the IES and automation help mitigate some of this cost, reducing the need for a crew as large as that of older carriers. The Fujian is, therefore, a high-value asset that signals the seriousness of China's global ambition. The power generation capacity of the IES on the Fujian is what prepares it for the future of naval warfare. China is investing heavily in naval drones and directed energy weapons, DEWs, such as lasers. The Fujian's enormous electrical power reserve will be essential to power these high-demand systems. The integration of drones, such as the future GJ-11, will allow the Fujian to extend its reconnaissance and strike range, operating in high-risk environments without putting pilots in danger. The Fujian is not just a carrier for manned fighters, but a command and control platform for a fleet of unmanned systems, ensuring its strategic relevance for decades. An aircraft carrier never sails alone. The Fujian will be the heart of a Chinese carrier vessel battle group, CVBG, which will include Type 055 guided missile destroyers, the Chinese super destroyer, comparable in some aspects to the American Ticonderoga-class cruisers, Type 052D destroyers, Type 054A frigates, and, crucially, nuclear attack submarine SSNs for anti-submarine protection. The ability to operate this CVBG cohesively and over long distances is the true test. The Type 055, in particular, with its 112 vertical launch system, VLS missile silos, will provide the long-range air defense and surface strike capability that the Fujian will need to survive in a high-intensity combat environment. China's integrated warfare doctrine is rapidly evolving to support the operations of a modern CVBG. The Fujian's christening location in Shanghai and its name, which refers to the province closest to Taiwan, are no coincidence. The main strategic role of this aircraft carrier is undoubtedly to project power into the Taiwan Strait and the South China Sea. The Fujian, with its catabar capability, can launch fighters with more fuel and armament, extending the Chinese anti-access area denial A22AD zone. In an invasion scenario, it would provide crucial air cover for landing forces and act as a mobile command center. Its presence in the theater of operations reduces the need to rely exclusively on vulnerable land bases, making the American and Allied response to a crisis much more complex. The Fujian is the missing piece in the puzzle of Chinese power projection in its immediate neighborhood. To ensure maximum retention, the narrative was structured to create an emotional and informative roller coaster. The opening is a geopolitical hook, establishing the Fujian as a threat. The size and power section uses high-impact adjectives: colossal, force multiplier. The electric revolution and emails are presented as secret weapons and quantum leaps, maintaining the mystery. The direct comparison with the USS Ford creates a clear conflict. The final narrative, teen twist, the insurmountable factor, experience, is a closing that surprises and invites reflection. The CTAs were strategically positioned after important revelations, technology, defense, and conclusion, and are varied: comment, like, subscribe, opinion, bell, avoiding repetition, and saturation. True superiority in modern combat lies not just in hardware, but in the speed and precision with which information is processed. The Fujian incorporates a state-of-the-art combat management system, CMS, which integrates data from all its radars, ASA, and sensors, as well as from other CVBG ships and airborne early warning (AEW) aircraft. This real-time data fusion creates a unified and accurate battle image, allowing commanders to make decisions faster than the adversary. This decision superiority is what transforms the Fujian from a mere warship into a floating command and control center, capable of coordinating complex operations across a vast theater of operation. It is crucial to recognize that China operates under a different doctrine. The discipline and ambition of the Chinese Communist Party to achieve military parity are factors that cannot be underestimated. While the U.S. may have the experience, China has the determination and resources to rapidly close this gap. The Fujian is the result of a long-term plan, executed with precision and without the budgetary and political constraints that affect Western projects. This determination, combined with rapid technological advancement, makes the Fujian a formidable adversary, even with the lack of practical experience in combat. Although the Fujian's conventional steam propulsion is its biggest drawback compared to the Ford's nuclear power, China has invested in significant refinement. The steam propulsion system is coupled to the IES, allowing for more efficient power management. China has mastered the technology of high-pressure boilers and high-power turbines, ensuring that the ship can maintain a speed of 30 knots. The disadvantage of the need for refueling is mitigated by the growing fleet of Chinese logistics support ships, AOR, which are being built to sustain long-range operations. The Fujian is the pinnacle of Chinese conventional naval engineering, a crucial bridge to future nuclear-powered carriers that Beijing will inevitably build.